Okay, on to problem 3. So this one definitely gave a lot of people trouble in class. I think, well, the actual math of it is pretty straightforward, but thinking about how to actually do it was the difficult part on this one. So we have a mattress on top of a car, and it's not attached at all, right? So the only thing holding it on is static friction. And so we are given the static friction coefficient. In this case, it's 0.7. And we're given the deceleration of the car, negative acceleration, right, of 11 meters per second squared in this case. And so it's asking whether or not the mattress will stay on the car. So let's draw a free body diagram as we do with all of our force problems. So I'm going to draw one of the mattress. So we've got gravity. So this is for the mattress. And we've got our normal force. Oops. Fn, there we go. And now let's think about the static coefficient of friction and the acceleration. So if the mattress stays on the car and doesn't slide off, then the mattress is going to undergo the same acceleration as the car. So as the car decelerates, comes to a stop, the mattress has to also accelerate or decelerate at that same rate, right? So let's say the car is moving. So the velocity of the car is moving this way. So it's moving left to right. That means that the acceleration of the car is going to be opposite that. So it's going to be backwards. Right, so the acceleration is going to be backwards. So that means that we have to have a friction force that is able to cause that acceleration. Basically, it's able to hold the car, or hold the mattress on the car with that acceleration happening. So naturally, if the velocity of the car was going to, now I'm backwards in my picture, but is going to the right, the mattress will want to fly off and keep going with that same velocity, but the acceleration is holding it on. So our friction force, static friction force, is going this way. So the static friction force has to go in the same direction as the acceleration. Okay, so those are the only forces on this. We can do some of the forces. Let's choose a coordinate direction. Pretty simple here. All three forces are perpendicular. So I'm going to do the x direction, some of the forces, since that's where the acceleration is. So the acceleration is not 0 in this case, right? We actually have some acceleration. And the only force in the x direction is the static friction force. It's the only thing holding it on the car. Okay, so I'm going to put a question mark over this equal sign. So this will only be true if the static friction is enough to cause this acceleration, right? If our force of static friction, if the left side of the equation is too small, we won't be able to get this acceleration out of it. So let's plug in our definition of static friction. Mu s times the normal force. Normal force is going to come from our y direction. Theoretically, we should do a sum of the forces in the y direction. We can see, however, that there's only two forces, gravity and normal force, and there's no acceleration in the y direction. The car is not jumping up off the road. So I guess for completeness, we can do that. Sum of the forces in the y direction. There's no acceleration in the y direction, and we just get positive Fn equals Fg, which is mass times gravity. So in this case, the normal force is actually equal to the gravity force. So we can plug that in here. We get mu s mg equals max. This is why I didn't give the mass. It actually cancels out here. So we can divide it from each side and get rid of it. So now, if mu g is equal to the acceleration, I should keep this question mark, right? We're not sure if this is equal. If mu g is greater than or equal to this acceleration, then the mattress stays in the car. If not, then it doesn't. So let's calculate what mu g is. 0.8 times gravity. Oh, sorry, 0.7 in this one. It's just 6.86 meters per second squared. So the acceleration that I gave is 11 meters per second squared. So in this case, the mattress flies off the car. Basically, the static friction force is only enough to decelerate the mattress at 6.86 meters per second squared, and it's trying to decelerate it at 11 meters per second squared, so it cannot. So it slides off. All right, that was number 3.